Hello, ladies and gentlemen. Welcome back to some more talking about square roots. Today, we're going to be talking about how we can figure out the value of a very, very large perfect square by making some good guesses and by knowing some smaller perfect squares that we can kind of arrange around it, okay? So how can we kind of estimate these really large numbers and make some good guesses about what they're going to equal? Before we do any of that, though, we do need to make sure that we know, at the very least, our first 10 perfect squares, because we're going to be looking at some really large numbers, and if we don't know these small perfect squares, these 1 through 10 ones, it's going to make it a lot harder to do what we're going to do. Now, yesterday I showed you these, right? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. But I also want you to think about what happens when we put a 0 next to the number we're multiplying by itself. So, for example, if I'm doing 10 times 10, instead of getting 1, I'm going to get 100. If I'm doing 2 times 2, but now I'm doing 20 times 20, instead of 4, I'm going to get 400. If I do 30 times 30, I'm going to get 900, and so on and so forth. Basically, it's going to add on 2 zeros to all my numbers that are my perfect squares. Because the number that's being multiplied to get them, I'm putting a 0 on the end. Again, the reason why we're talking about this is because in a moment, you're going to see that we're going to be looking at some really large numbers, and we're going to kind of use these to create almost like a little bit of a estimate for us so we can figure out what those really large perfect squares are equal to, okay? So here are my kind of multiplied by 10 perfect squares, where I have this one's 10 times 10, 20 times 20, 30 times 30, 40 times 40, 50 times 50, so on and so forth, all right? Now, let's get into the good stuff. Let's see why we're talking about this or what kind of problems we're going to be asked to do. Basically, I'm going to give you these really large perfect squares. So here we have 2,809, and without a calculator, just by making some good guesses, I want you to tell me what that perfect square equals. Mr. Guy, that's crazy. How can I ever figure that out? Well, we're going to basically be creating intervals around these that we can make some good guesses and some good estimates. So let's start with this one, 2,809. The first thing I want to do is I want to figure out what are some numbers that are near 2,809 that are perfect squares that I know. So my two numbers I came up with were 2,500 and 3,600. And just to show you where that came from, if we look back over here at our list of perfect squares, yeah, remember 2,500 was 50 times 50, and 3,600 is 60 times 60, okay? So those are perfect squares, and 2,809 fits right in between those two perfect squares. So I'm going to pick those two as kind of what is wrapping around it. So the range I'm going between, I know the square root has to be between 50 and 60. And again, I know that because I know the square root of 2,500 is 50 and the square root of 3,600 is 60. This number falls in between. Its square root needs to fall in between as well. Once I figured out that range, I'm then going to go ahead and make some good guesses. Well, Mr. Guy, how do I make good guesses about this? The key is the last number in your square root. The last number in your square root. The last number in this instance is 9. Think about what numbers times themselves give you a number that ends in 9. I can think of 2 single-digit numbers that do that. I can think of the number 3. 3 times 3 is 9. And I can think of the number 7. 7 times 7 is 49. So, what numbers end in 3 and 7 that are between 50 and 60? So my good guesses are that the answer to this problem is either going to be 53 or 57. 3 times 3 gives me 9. 7 times 7 gives me something with 9. So I know that one of these two has to be my answer. All right, well, Mr. Guy, you boiled it down. You got us down to 2 options here. How do I know which one of those options is the actual answer? Well, the way that you know that is by looking at your original number and saying, what's it closer to? Is it closer to the 2,500? Is it closer to the 50? Or is it closer to 3,600 and closer to the 60? If it's closer to the 50, it's probably 53 because that was close to the 50. If it's closer to the 60, it's probably 57 because that was closer to 60. This number is closer to 2,500, so my answer is going to be 53. Let's do another one. Let's see if we can do another one here. Okay, so here's another one, 5,476. I'm going to come up with a range, and then I'm going to go ahead and try to make some good guesses and get an answer. So the first thing is I need these perfect squares to kind of surround this to give me this range that I'm looking for. And in this instance, the two perfect square numbers I'm looking for are 4,900 and 6,400. So that means 4,900 is 70 times 70, 6,400 is 80 times 80. The answer to this problem is going to be somewhere between 70 to 80. Now that I know that, I want to look at this last number. In this case, it's 6. So I think to myself, all right, what single digits multiply by themselves to give me 6? And once again, I can think of two different single-digit numbers that do that. I can think of 74, and I can think of 76. 4 times 4 is 16. 6 times 6 is 36. Those both end in 6. This ends in 6. These are the two numbers that it could possibly be. Now I'm going to do the same thing I did last time. I look at this number up here, 5,476, and I say, all right, is it closer to 4,900 or is it closer to 6,400? And again, you can kind of estimate it a little bit. It's about 500 away from 4,900, but it's almost 900 away from 6,400. So it's closer to this one. 74 is closer to 70, so my answer is going to be 74. Plus or minus, because I put that in front here to show I want the primary and the secondary root. Okay, so once again, we're figuring out these bigger perfect squares that fit around this number. We're saying, all right, here's what their square roots are. Because it ends in a 6, it either has to end in a 4 or 6, because those are the things that multiply and give me 6. And then it's closer to 4,900, which square root was 70. 74 is closer to 70. It must be 74. I want you all to go ahead and pause the video and try this one on your own, and then we'll meet back and we'll talk about it. So go ahead and try this one, see if you can come up with your range, your good guesses, and your answer. All right, and we're back. Let's go ahead and let's check our work here. So I said that this one was between 1,600 and 2,500, meaning my answer was between 40 and 50. The good guesses here would be either 42 or 48. Sorry, that should say 48. Okay, but it should be either 42 or 48. And because that 2 times 2 ends up in 4, 8 times 8 ends in 64, this number is definitely closer to 1,600, so 42 is going to be my answer. Here's another one. I want you all to, again, do the same thing. Go ahead and pause the video, see if you can come up with a range, good guesses, and answer, and then we'll meet back and we'll talk about it. So pause the video, do that, and then come back and we'll talk about it. Okay, so if you go ahead and you take a look here, I said this one fell between 6,400 and 8,100. That means that my range is from 80 to 90. The two ones that will multiply and end in 1 will be 1 and 9. So 81 and 89 are my two numbers. 9 times 9 is 81, so that's why it's that one. And so my answer is 81 because this is much closer to 6,400 than 8,100, and 81 is closer to 80. Now, if you'll notice, I'm actually missing something here. What should be here? Oh, Mr. Guy, they asked for the secondary root. You didn't give us the secondary root. Make sure you're paying attention to that. There actually should be a minus 81 here, okay? Negative 81 should be your answer there. All right, last one for you to try. Go ahead and try this one. Tell me your range, your good guesses, and answer, and then we'll meet back and make sure we're all on the same page. All right, taking a look at our answer here, I have 2,500 as my perfect square below, 3,600 as my perfect square above. That means that the answer is going to be somewhere between 50 to 60. I know that the two numbers that when I multiply and they end in 6 are 54 and 56. 2916 is closer to 2,500 than it is to 3,600, so 54 must be my answer because that's closer to the 50 than the 60, all right? So this is how we can use good guesses and our knowledge of perfect squares in order to estimate these larger perfect squares that I may not already know, that are kind of too big to just know off the top of your head, okay? So go ahead and make sure you practice this, and I hope you guys all have a nice day. Thank you for watching.